Hi, hello, good morning, one and all. Today we are going to discuss about one of the application of Gauss law. So before discussion about Gauss law application, basic things first we should learn. So what are the basic things? Spherical or sphere related. Sphere related bodies. Sphere is again two types. One is shells and solid. Shell means already we know basic thing plastic ball. So plastic ball. What is plastic ball meaning is? So the mass particle can distributed entire outer surface, but inside is empty. This type of bodies are called as shell. Next one is solid. Solid already we know that opposite. The mass particles can be distributed entire volume. For example, shot put ball, right? It is basic thing. Again, according to electricity related topic, shells or solids two types. First one is conducting conducting shells. Second one is non-conducting shell. Shell or sphere, anything. Sphere means here solid also. Conducting, non-conducting. Conducting shell or non-conducting shell. A conducting solid or sphere, non-conducting solid or sphere. Solid means nothing but here shape is mainly sphere. So solid means entire mass particle can be distributed. So it is solid. Total entire mass particles can be distributed. Total body. Entire volume can be exist mass particles. But shell is only outer surface only mass particles can be exist. This is shell. Right. So again here conducting, that is the main thing. Conducting and non-conducting. Most of the students are confusing here conducting and non-conducting. Conducting meaning is, so for example shell only we should consider. So conducting shell means the particles or charges, particles that exist on the surface, okay. At the same time charges also resides at surface, on the surface. Charges can be resides on the surface of a shell. That shell is called as conducting shell. Charges can exist, so it is conducting shell. Conducting sphere or solid sphere. Solid sphere is, so here totally entire volume of a body exists mass particle. So here charges also exist entire volume of a body. So this is solid sphere is non-conducting. It is conducting shell. Here also entire volume means on the surface and inside also charges can be exist. So it is non-conducting. But what is the conducting sphere? Conducting sphere means same. It is sphere. Sphere means mass particles can be exist. Entire mass particles can be exist, but charges can be exist only on the surface. So it is sphere, Nana. It is sphere, but here charges can be exist only on the surface, but inside charges is zero. This type of bodies or solids are called as conducting sphere. So it is also called as conducting conducting sphere. Conducting sphere, conducting shell. Understood my topic? So here main once again, the body can exist charges only on the surface of a body. On the surface means, for example, not only like this, it is not ring, it is a three-dimensional. Three-dimensional means here positive charge, positive charge, positive charge, entire here this side or this side, entire surface exists positive charges. So this is called as conducting sphere or conducting shell. But inside the body, no charges can be exist in conducting bodies. So, but here, non-conducting bodies means entire volume can exist charged particles or charges. So now here, and one other definition is there. So positive charges or negative charges only resides at on the surface, but these particles or free electrons is exist in conducting sphere or conducting bodies or shell. So but here electrons can be bounded with positive charges. There is no free electrons. The type of bodies are called as non-conducting sphere or non-conducting shell. So non-conducting meaning is here indirectly insulator. Already we know that insulator meaning. Insulator means what? It does not conduct any electricity through them. And also it is also called as dielectric material. Dielectric material. Dielectric substance. So dielectric means the positive and negative charges can be exist and tightly bounded. That's why there is no any free electrons. So the type of bodies are called as non-conducting sphere. Non-conducting spheres. Understood ma here? Conducting, non-conducting difference. First, charges can be exist only on the surface. The type of bodies are called as conducting. Charges can be exist entire volume of the body, that is called as non-conducting bodies. A shape is sphere, that's why shape sphere, or shape is empty is there means shell. So that is the difference. Right. Now we are going to discuss about Gauss law application. Electric field due to a spherical shell. Spherical shell. So now here, electric field due to a spherical shell by using Gauss law. So right, it is one of the important 5 marks question. Right now, consider a spherical shell. First, we should consider one spherical shell. Spherical shell. What type of shell? Conducting shell. So, here conducting spherical shell. Conducting meaning already we learned. Positive or negative charges can be exist only on the surface. So, this is conducting spherical shell. Its radius is considered as capital R. Capital R only considered. So now here, Gauss law is applied for any body. So we should construct one Gaussian surface. One Gaussian surface, uniform Gaussian surface around the conductor. Remember, Nana, Gauss law application or Gauss law is applied means 100% we should consider Gaussian surface. We should construct around the conductor. So this is Gaussian surface. Gaussian surface. So in this Gaussian surface, it is what shape is there? Spherical shape. Why? Because conductor is also sphere. Sphere. So now here, so we want to calculate electric field on the surface. So Gaussian surface only we should consider. This is one small surface area only you should consider. The surface area is ds. So already we know the properties of electric field lines. Electric field lines can be passes from charge. So electric field lines can be passes like this direction. So outward direction. So why? Because not only here all directions electric field can be passes outward direction. So that is main property of electric field line. Next, it is ds means small surface area on the Gaussian surface. So we want to calculate my electric field at point P on the Gaussian surface. So here Gaussian surface electric field lines passing perpendicular to the surface. The number of electric field lines are passing perpendicular to the surface or closed surface is called as what? Electric flux. The number of electric field lines can be passes perpendicular to the closed surface or normal to the surface is called as electric flux. So now here, so not only electric field passing like this way, so here we should consider a small surface area. So electric field lines can be passes from this side. The same time, here once consider small surface area, electric field lines can be passes like this. So here we should consider electric field lines can be passes like this. So here what intensity, what is the strength of electric field value at distance P, at point P from the center to P point distance is smaller only consider. So here also same regular sphere, it is Gaussian surface. That's why from here to here distance is also smaller. From here to here center to at point P distance is smaller. So from here to point P distance is smaller. So everywhere distance is smaller only. This point can exist outside from this sphere. So which is on the surface of Gaussian surface. So now here point P to center of the shell distance is smaller only. You should consider the radius of the shell only smaller, capital R, but distance is considered as smaller from here to here smaller only. So here once you observe diagram, this electric field lines can be passes from where? From the center. From the center all electric field lines can be passes from the center. It seems like that. Why? Because the all electric field lines can be passes from charges only, but here it seems like this. From this line is drawn from the center like that only there. That's why from we should take distance from center of this shell or sphere to point P distance that is smaller. Great, understood. So once again here diagram. Right. See here, it is spherical shell, spherical conducting shell. It is non-conducting. It is not non-conducting. It is conducting shell. So we should construct on Gaussian surface around this shell. Gaussian surface around this shell. Right. So the radius of this shell is capital R. And here Gaussian surface, this is Gaussian surface. Right. So now we should construct one small surface area So the surface area is ds. So from center of the shell to point P, here we should consider point P distance is small or only consider. So here electric field lines can be passes perpendicular to the given surface, that is electric flux. So how do we know that? Electric flux phi is equal to what? E into ds cos theta. E into ds cos theta, remember it is previous topic. Once you observe that video, so E into ds, electric field, small surface area, cos theta. So cos theta y means, so his surface area and electric field are, so here normal vector and electric field is both are in same direction. So same direction means theta is equal to 0 degrees. So that means maximum flux will be passes, maximum electric field lines can be passes through the surface area. So now here phi is equal to, if theta equal to 0 degrees means here E into ds, cos 0 value 1. So already clearly explained in previous topic, once you observe that electric flux related topic, so you can easily understood. So right, it is phi equal to E into ds. So now for total, for example, now we should consider only small surface area, but we want to calculate total shell produces electric field entire Gaussian surface. For that purpose, we want to integrating the above equation. So integrating above equation. So integrating means, integration already we know that according to mathematics. So phi is equal to integral E into ds. Why integration here? Actually ds is there means actually here ds, sorry d phi. So now here integration d phi means phi only will come. So directly I written. So integration E into ds. So now phi is equal to, E is electric field is common thing which is can be processed in all directions. So entire surface, entire shell, it can be produces equal ratio of electric field lines. So that's why electric field is constant. Take it outside. Integration ds. Integration ds, integration value form is what? S. So it is phi. Here it is. S means what? Here S is what surface area? It is ds. It is surface area means what shape is there? Spherical shape. So S means Gaussian surface area. Gaussian surface area. Gaussian surface area, what shape is there? Sphere shape, spherical shape. Spherical shape surface area is 4 pi r square. R, what r? Small r. Why? Because from center of the shell to this Gaussian surface distance is small r. That's why small r square. Understood? It is formula for formula in mathematics, basic formula. So S means Gaussian surface area. So formula is 4 pi r square. So this value substitute here. So phi is equal to E into 4 pi r square. So now here it is what application? Gauss law application. What is Gauss law? The total electric flux. Total electric flux is equal to 1 by epsilon naught times the net charge enclosed by the surface. Net charge enclosed by the surface. For example, this surface is encloses. So with charges is capital Q only consider. That's why here Q by epsilon naught. This is Gauss law. Understood? Remember Nana, Gauss law application. Gauss law means total flux. So total flux enclosed by that surface is equal to 1 by epsilon times the net charge. So that is Gauss law. So here also it is total flux. Why? Because already integrated. Integrated means not only small surface, it can be used entire surface area. Right. So now here total flux equal to Q by epsilon naught. So this value substitute here. So Q divided by epsilon naught is equal to E into 4 pi r square. So now here E is equal to, E keep here this 4 pi r square move this side. So what happens? So Q already is there divided by 4 pi. Here epsilon naught is there, epsilon naught. Here multiplying move this side means divides. So 4 pi epsilon naught into r square. Understood? It is multiplying. This total term move this side. 4 pi r square into epsilon naught will come. So but epsilon naught is mixed in front of r square. So E is equal to, finally it is also written as 1 by 4 pi epsilon naught q divided by r square. So this is electric field due to a spherical shell outer point, that means at point P outside from the shell. So inside shell is there, and on the surface shell is there. Next class I will explain that one. So okay, thank you. I hope you understood.